Let's talk about the wave power formulas. Here are some pictures of things that harvest energy from wave power. I think this one does it by just bending like that to follow the waves. Some of them use the up and down motion, so that's what's going on here, is that they're generating electricity by the up and down motion of this. Some of them actually have like a little thing that impounds the water, so it goes over this, right? And then when the water breaks here, it has to go out through little turbines. Some use the energy of tides, but that's a different thing. That's just like a hydroelectric dam. But anyway, yeah, so let's look at the formula. Here's the formula, and notice that they give it to you as power per unit length. Notice that A on the last formula was area. Here it's the amplitude. It's just how high the wave is in meters, right? So if you've got a wave, it's like this, right? The amplitude is this distance here. The distance above, and I think what this works out to be is the mass, the potential energy of this mass of water raised up above. The formulas, if you try to explain this, the formulas that you'll find on the internet are highly contradictory. Now everybody's got their own wave formula. I think it's actually a very complicated formula that IB has simplified for us. So I'm not going to try to derive this formula. Okay, but let me just show you how to use it. You probably want to write this down here. The G in this case is just our G, right? Okay, so let's see. 210 meter. So basically what we're going to do here is, this question asks about 210 meters of it. This formula will give us the energy for 1 meter, and we'll multiply by 210 to get the energy for 210 meters, right? So per meter, right, our energy is 1/2. The amplitude, not the area, but the amplitude, right? So that is, what, 2.3 meters. Okay, you got to square that, right? Then times 1,030. So remember that distilled water is, of course, 1,000 kilograms per cubic meter, but salt water's got salt in it. So apparently a cubic meter's got 30 kilograms of salt, which is somewhat amazing, right? Okay, so there's our density. Got to multiply by 9.81. Right, and this is newtons. Let's put the units in there. Kilogram, right? This is kilograms per cubic meter. This is meters, right? Let's see, velocity is meters per second, 3.8 meters per second. Okay, now if you look at these units, this is meters squared. It cancels all but one of those. That meter cancels that one. Kilograms cancels kilograms. You get newtons per second, which is like, what is that, right? But remember, that's per meter. To get the power, you've got to multiply by meters, so you'd end up with Newton meters over seconds. So that's a joule per second. That's a watt, right? Which is what it should be, right? Okay, so let's see. Let's do this. On the calculator, 0.5 times 2.3 squared times 1,030 times 9.81 times 3.8. And I'm getting 101,558 watts per meter. That's amazing. Wonder what the efficiency of these things. It must be dreadful, or this would be like the end all be all, right? 1 meter of coastline, right? If you could trap all that energy, right? Okay, so if there's 210 meters of it, right, then it's going to be times 210 meters, right? So that times 210 is, wow, that's a lot. 0.1327 times 10 to the 7th. What's that unit? Yay.